All right, let's convert from standard form to vertex form using completing the square. I'll go through one quick example. Let's jump in. Okay, so as a first step, and you can see my solve by completing the square video as another refresher. I like to move this c value over. So this will leave us with p squared plus 16p, intentionally leaving a little space here, equals 22. Now, what do we put in this space? I'll make a little side note over here, right? This is what goes in this space. We use b over 2 squared. In this case, our b value is 16, so this would be 16 over 2 squared, which equals 8 squared, which equals 64. Okay, so that is our special value that we need to add here in order to make it a perfect square. But we can't just do it to one side of the equation. We have to do it to the other. So what are we left with? P squared plus 16p plus 64 equals 22. And why would we go through all that business? Well, we've created a perfect square on this side. And what does that mean? If we were to factor it, we would get our, it's always going to be b divided by 2. If we were to factor this, we would get p plus 8 and p plus 8, because 8 times 8 is 64 and 8 plus 8 is 16. But the cool thing about it, when they're the same, you can represent it differently, and you can just simply call this p plus 8 squared. P plus 8 squared equals 22. And this should start looking quite familiar. If we simply subtract 22 from both sides, we get p plus 8 squared minus 22. We could throw a y in front of it. And this right here is our vertex form. So we know our vertex is the opposite of this one. So that would be a negative 8, comma, negative 22. So this is our vertex. This here is our vertex form. Vertex is always the opposite of this one, comma, this one as it is with its symbol.